Hello everyone. Today we're going to explore one of the most important tasks in operating system called process management.
Let's start with the basic. A process is a program in execution. When you open a browser, a game, or a document, the operating system turns that program into a process. Each process needs CPU time, memory, input-output resources, and access to files. Each process goes through different states during its lifetime. The main ones are new, ready, running, waiting, and terminated. New means the process is being created. Ready means the process waiting to be assigned to the CPU. Running means the process instructions are being executed. Waiting means waiting for some event like user input or file access. Terminated means the process has finished execution. To manage all this, the OS keeps track of each process using a process control block or PCB.
Think of it like an ID card for each process. It stores process ID, current state, program counter, input-output status, CPU register, and memory info. When the OSs switch from one process to another, it performs a context switch. It saves the current state of the running process and loads the next one. This will allow the multiple processes to share the CPU efficiently.
To decide which process run next, the OS uses scheduling algorithms like first come first serve, shortest job next, round robin, and priority scheduling. Each algorithm has pros and cons depending on the system needs, hence speed, fairness, or responsiveness. When multiple processes need the same resources, the OS handles synchronization to avoid conflicts.
But sometimes it can lead to a deadlock, where the processes are waiting for each other forever, and the OS must detect and solve the issue.
Wait, why do I think I forgot something? Oh. So what is a thread? A thread is the smallest unit of execution in a program. You can think of it as a single path of instruction that CPU follows step by step. In a process which is an instance of a running program, a thread is responsible for doing the actual job, which is executing the code. Every process has at least one thread, called the main thread, but a process can have multiple threads that run different parts of the code at the same time. So, what does it have? Each thread has its own program counter, stack, and registers. However, all threads in the same process share the same code, the same data, and the same files. These sharings allow threads to work together efficiently, but it also means that they need to be carefully managed so they don't interfere with each other. Alright, this can be quite long, so bear with me. Okay, there is two types of threads, a single thread and multi-thread. Let's start with a single thread. This is the process where there is only one thread of control. That means the program can only follow one path of instruction at a time. There is just one program counter, one stacks, and one CPU registers. This type of process runs everything step by step and cannot do more than one thing at the same time. It's simple but not always efficient, especially on modern computers that have multiple cores. Now let's take a look at multi-threaded process. These are also called lightweight processes, and they allow a program to have multiple threads running at once. Each thread has its own program counter, its own stacks, and its own set of registers. So each thread can run its own set of instructions, sometimes at the same time as others, especially on multiple core CPU. What's interesting is that even though the threads are separate in terms of executions, they share the same memory space. That means they all use the same code, the same data, and the same access to the same open files. This makes it easier for the threads to communicate and work together. For example, in a web server, One thread can handle users' requests, another can read files, and another can send data back to users at all the same time. Because of this, multi-threading helps make program faster and more responsive, but it also means the operating system needs to handle scheduling, synchronization, and resource sharing carefully so that threads don't get in each other's ways.
So in summary, process management ensures smooth program execution. It tracks states, deadlock, handles schedule, and keep your system responsive. Without it, your system won't be able to multitask at all. Thanks for watching. I hope it gave you a clear understanding of process management in operating systems.